students. Let's start lecture number 7.
Let's start the new point, similar triangle. On screen, you observe there are two triangles, triangle ABC and triangle DEF. Okay, and these are the identical marks. Okay, so according to identical mark, what one can say by simply looking on this figure, this identical mark says angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Okay, now we will able to understand these angles are congruent with correspondence. This A is corresponds to D, B is corresponds to E, and C is corresponds to F. But what does similar triangle means? Okay, so let's learn this. In triangle ABC and triangle DEF, if angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Okay, that we get from identical marks. And also, see, this is very important condition. AB upon DE is equal to BC upon EF. AB upon DE is equal to AC upon DF. BC upon EF is equal to AC upon DF. Okay, so these are the ratios of corresponding sides. Okay, see this AB upon DE. What is that? AB upon DE, which is equal to BC upon EF. So this ratio is equal to ratio of these two sides. Okay, if it is same, similarly, if the ratio of these two sides and these two sides is same, and if the ratio of these two sides and these two sides is same, then these two triangles are similar triangles, and this can be expressed mathematically in this way. See this. This is horizontal S. We can write horizontal S in between these two triangles to represent it mathematically. In order to find similarity between two triangles, we need three pairs of congruent angles. See, this is one pair, second pair, and third pair, and three pairs of ratio of corresponding sides in the same proportion. So these are the three pairs. This is one pair, second and third pair of whom of ratio of corresponding sides. Out of these three six conditions, if three specific conditions are fulfilled, then the remaining conditions are automatically fulfilled. So, out of these six, see these are total six: 1, 2, 3, 4, 5, and 6. These are the six conditions that we need to check whether the given two triangles are similar or not. But what they say, out of six, if we just check three only, then the remaining conditions are automatically fulfilled, and only three specific conditions are sufficient for similarity of two triangles. So we no need to check six conditions every time. We can simply check three conditions, and then we can confirm or surely say that these two triangles are similar. The group of such sufficient conditions are called tests of similarity. There are three tests of similarity. So we will discuss this, we will learn this one by one. There are three tests. The first test is AA test of similarity. The second is SAS test for similarity. And last one is SSS test for similarity. Let's discuss each test one by one. The first test is AAA test for similarity. The statement of this test is, for a given correspondence, if three angles of one triangle are congruent to the corresponding three angles of other triangle, then the two triangles are similar. Here, triangle ABC and triangle PQR, these are the two triangles, and we have to prove that these two triangles are similar using Aaa test. So what condition is to check whether these two triangles are similar according to Aaa test? Let's see. Here triangle ABC and triangle DEF are in correspondence, that is ABC is corresponds to PQR. Now this correspondence we already learned in 8th standard. What does it mean? ABC corresponds to PQR. It means vertex A is corresponds to vertex P, vertex B is corresponds to vertex Q, and vertex C is corresponds to vertex R. Similarly, side AB is corresponds to side PQ, side BC is corresponds to side QR, and side AC is corresponds to side PR. This is what the correspondence means. Okay. Now, if three angles of one triangle, suppose this is triangle ABC and this is the first triangle, are congruent to the corresponding three angles of another triangle. Now this is another triangle PQR, and triangle angle A, angle B, and angle C are congruent to angle PQR in correspondence. Means angle A is congruent to angle P. As you can see this is 55 degree, and again this is 55 degree. So angle A and angle P are congruent. As they as this information is given, so we can use this in order to prove this. These are the similar. Okay. In the next pair, angle B and angle Q, as they are having equal measure, which is 70 degree, so they are congruent. And angle C and angle R, again 55 55, so angle C and angle R are also congruent. So if these three angles are congruent with these three angles with correspondence, then we can say the triangle ABC and triangle PQR are similar triangle. There is a difference between congruent and similar. Okay, and we are just going to check this test in order to prove whether they are similar or not. We are not interested to prove them congruent. Okay, don't get confused yourself. To find this similarity, we required only three conditions. See this? Only three conditions are required. This is the first condition. This is the first condition. Okay. This is first condition. This is second condition we are going to check, and this is third condition. That's it. These three conditions are only required to check the given pair is similar according to Aaa test or not. Now, if you move further, we will have one more test which is coming from this Aaa test, and the name of this test is Aaa test. What does it say? When two angles of one triangle are congruent to two corresponding angles of another triangle, then this condition is sufficient for similarity of two triangles. This condition is called Aa test of similarity. Now this is very interesting. See, Aa test, one A is missing. It means we don't need to check out of three, only two pairs we have to check whether these two pairs are congruent with these two, whether these two angles are congruent with these two angles. Okay, we no need to check angle C and angle R are congruent, because automatically it will be congruent, as the sum of measure of angles of a triangle is 180 degree. Then 70 and 55, 70 plus 55 is 100 plus 25, so it's 125 degree, and the last angle must be 55 degree. If it is in this case, then in this triangle also the last angle, which is remaining R angle, must be 55 degree. So this automatically will be equal measure. So one thing we have to do, that we have to simply check the two angles of a given triangle are congruent with two angles of another triangle, instead of checking three angles. Okay, if you observe carefully, we are collecting the minimum information from the given diagram in order to prove them similar. Okay, this is the best way to represent the given pair of a triangle is similar. So in this way, we will learn AA test for similarity and AA test for similarity. AA test for similarity is coming from AAA test for similarity. So both are similar except one A is missing. It means we no need to check extra angle to be congruent with another angle of another triangle. That's it. Otherwise, both the pairs are same. No problem. Okay. The next test for similarity is SAS test. In this test, for a given correspondence, if two pairs of congruent corresponding sides are in the same proportion and the angle between them is congruent, then two triangles are similar. Okay, this is the statement of this test and we have to check it. Here, for triangle ABC and PQR, ABC is corresponds to PQR. It means vertex A is corresponds to vertex P. Vertex B is corresponds to vertex Q and vertex C is corresponds to vertex R. Now, what we have to check? Only three conditions, which are the first one is AB upon PQ is equal to AC upon PR. See this AB upon PQ. So AB is 3, PQ is 2 centimeters. So 3 by 2 is the ratio AB upon PQ. And AC upon PR. AC is 6 and PR is 4. So 6 by 4 is reduced form is 3 by 2. So again we get 3 by 2 here. It means this condition is satisfying. First condition is satisfying because we got 3 by 2 ratio for both LHS and RHS. The next case in the next condition is triangle A is congruent to triangle P. See this 35, 35. Angle A and P. Both are having equal measure, so they are congruent. Now, where is next condition? This is the question. Okay. We no need to find another ratio because we are just checking this side and this side, this side and this side in this form. Okay. Here AB, AC. PQ and PR. So we are already taken one length as a AB and another length as a AC. So already we finished our three conditions, that is two sides and angle between two sides. We are not taking this angle or that angle. If we are selecting AB and AC, then we have to check this angle only. Hence, the name is SAS. Otherwise, it can be SSA, but this is not possible in this case. So, as according to the name SAS, we have to take side, angle, and side. That's it, and check whether this angle is congruent with that according to the correspondence. Okay. So this is what SAS test for similarity, and by checking this condition and this condition, although it looks like two conditions, but they are actually three conditions because we are actually considering three sides, three sides. That is this one side. I'm sorry, this one side, this angle, and this is another side. These three things we are going to check. Hence, this is three condition required case. Okay. So SAS test required two sides and one angle making made by these two sides is congruent with another triangle of same side and same angle. That's it. This is what SAS test for similarity. Next test is SSS test for similarity. This is side test. Okay, so in this test we have to check, again three conditions are required. That is, we have to check the ratio of corresponding sides of a given triangle. So if you take AB upon PQ, which is mentioned here, AB upon PQ has to be equal to BC upon QR. Again, BC upon QR has to be equal to AC upon PR, and finally AB upon PQ is equal to AC upon PR. Okay, so this is what the required condition is. So statement for this test is, for a given correspondence, if three sides of one triangle are in proportion with the corresponding three sides of another triangle, then the two triangles are similar. So see, this we have to check this corresponding sides and their ratio. If the ratio is same, then we can say the given two triangles are similar according to SSS test. This is what all three tests are. There are three properties of similar triangles. First is reflexivity. It means triangle ABC is similar to itself. Triangle ABC. Very easy property. Another second property is symmetry. If triangle ABC is similar to triangle DEF, then triangle DEF is again similar back to triangle ABC. Third property is transitivity. If triangle ABC is similar to triangle DEF, triangle DEF is similar to triangle GHI, then triangle ABC is similar to triangle GHI. So if these two are similar and these two are similar, then this and this are again similar. So these are the three properties of similar triangle. Proof for Aaa test statement. For a given correspondence, if three angles of one triangle are congruent to the corresponding three angles of other triangle, then the two triangles are similar. So this is the statement. We already studied this statement. Now we will prove this in this theorem. Okay, here are the diagrams and we have to write down the proof for it. Given. So according to this statement, we will find given and to prove. The given says in triangle ABC and triangle PQR, angle A is congruent to angle P. See this from diagram. These are the identical marks. Angle A and angle P are congruent. It means they are corresponds to each other. Now angle B and angle Q are also congruent. They are also corresponds to each other, and angle C and angle R are again congruent and they again corresponds to each other. So what is the correspondence? Because for a given correspondence they have mentioned, so here the correspondence is ABC corresponds to PQR. Okay, ABC which corresponds to PQR. Okay, now let's back to the theorem. So angle A, angle P, B, Q, and C are the congruent angles to each other. To prove angle ABC similar to triangle PQR, ABC and PQR we have to prove similar to each other. Construction. First construction is draw triangle ABC bigger than triangle PQR. So here I am taking ABC is little bit bigger than PQR. Second, in triangle ABC, draw line MN which touches side AB at point M and side AC at point N. बघा लाईन एम जी आहे पॉइंट एम जो आहे तो काय करतोय ए बी ला टच झालाय बरोबर आणि पॉइंट एन जो आहे तो एसी ला टच झालाय जेणेकरून आपल्याला काय मिळतंय एम इज इक्वल टू पी क्यू अँड एन इज इक्वल टू पी आर एम आणि पी क्यू हे आपल्याला इक्वल मिळाले पाहिजे त्याप्रमाणे आपल्याला ही जी लाईन आहे ड्रॉ करून घ्यायची दिस इज व्हॉट द कन्स्ट्रक्शन सेज एम इज इक्वल टू पी क्यू अँड एन इज इक्वल टू पी आर प्रूफ in triangle AMN and triangle PQR segment AM is congruent to segment PQ see this according to the construction आत्ताच आपण बघितलं angle A is congruent to angle P again इथे आहे given आहे ते segment AN is congruent to segment PR again this is construction हे बघा इथे दिलं आपण okay and last is triangle AMN सो ह्या सगळ्या गोष्टी जर आपल्या समोर असतील तर बघा आपल्याकडे दोन सेगमेंट्स आहेत दोन सेगमेंट्स आहेत आणि एक अँगल आहे त्याच्या पेअर्स आहेत ठीक आहे सो ए एम पी क्यू त्याच्यानंतर हा जो अँगल ए हा अँगल पी आणि ए एन पी आर असं जर असेल तर हे जे डार्क तुमचा ग्रे कलर मध्ये जो पोर्शन आहे अँगलचा हा आणि हा, हे दोन जे अँगल आहेत ट्रायंगल्स आहेत, हे दोन्हीही ट्रायंगल्स कसे आहेत, कॉन्ग्रुअंट झालेत. आता इथे कॉन्ग्रुअन्सी कुठली येते, तर एस ए एस टेस्ट लक्षात घ्या, इथे मी कॉन्ग्रुअंट लिहिलंय ना की सिमिलर लिहिलंय. सो कॉन्ग्रुअन्सी आपण गेल्या वर्षी शिकलोय, त्याच्या आठवीला शिकलोय, नववीला शिकलोय. सो इथे कॉन्ग्रुअन्सी आपण आधी प्रूव्ह करून घेतली. कोणाची, या दोन ट्रायंगलची, ट्रायंगल AMN and triangle PQR. So finally triangle AMN and triangle PQR are congruent. Therefore angle AM is congruent to angle Q. This angle, this is angle M and this is angle Q. This is congruent. Okay, why? Because corresponding angles of congruent triangle CACT. Okay, if two triangles are congruent, then their corresponding angles are also congruent. Now check this M and Q. So here the correspondence is A is to P, M is to Q, and N is to R. So M is congruent to Q. So this is the correspondence. But angle B is congruent to angle Q. Angle B is congruent to angle Q. This is given. Okay, this is given. And from the identical mark also we can observe. Okay, it's very easy. So angle B is congruent to angle Q is given, and angle M is congruent to angle B from 1 and 2. Now where is 2? 2 is missing here. So this is second. Let me write this. This is second equation, and from 2 and 1 we can conclude angle M and angle B are congruent because RHS is same. Okay, so 1 and 2, from 1 and 2, angle M and angle B are congruent. See this, angle M and angle B are congruent to each other because 1 and 2, which is the corresponding angle test. Therefore segment MN is parallel to segment BC. Now if this angle and this angle is congruent, then this line, which is MN, and side BC are parallel to each other. This is why, because of corresponding angle test. This test or this theorem you learn in 9th standard maths 2 chapter 2 and page number 20. You can go, if you have textbook from 9th standard, then you can go and check this. Okay, the next step is, according to basic proportionality theorem, we can write AM upon MB is equal to AN upon MC. See this, AM upon MB is equal to AN upon MC. Now why I am taking this step? As we have proved that MN and BC are parallel, we can apply BPT. Okay, we can apply BPT. Hence we can take this step. Yeah. So next is MB upon AM. MB upon AM is equal to NC upon AN. This is just inverse. So we are taking inverse of this ratio. Hence we command them by inverted. Again from 9th standard, ratio and proportion chapter, maths 1. By invertendo, componendo, such things we already discussed, learned in last standards. So I am taking here inverse of this step. Next step is I am doing componendo. So by adding denominator with numerator, numerator plus denominator upon denominator is equal to numerator plus denominator upon denominator. So MB plus AM upon AM is equal to NC plus AN upon AN. Let's see, MB plus AN is what? AB here. AN plus NC is what? AC. So we can write AB, AC, AB upon AM, AC upon AN. Okay. The comment is A dash M dash B. It means A, M and B are collinear. Similarly, A, N and C are also collinear. A and C, A and C. Therefore, AB upon PQ is equal to AC upon PR, which is the third equation. and this is construction. See this AB upon PQ is equal to AC upon PR. See, as AM is equal to PQ and AN is equal to PR, that we take in the construction here, AM is equal to PQ and AN is equal to PR, so that we can use this instead of PQ and PR instead of AM and AN. This is third step, third equation. Similarly, we can prove that AB upon PQ is equal to BC upon QR. In the same way, we can prove that AB upon PQ is equal to BC upon QR. Okay. So how do we get this ratio? To get this ratio, earlier we draw MN parallel to BC. Okay. But now we have to draw MN parallel to AC. Okay. In this way. In this way, if we draw, see this cursor position. In this way, if we draw a line and perform all these calculations, then we will get equation number 4 result. Okay. So finally, from equation 3 and equation 4, the LHS of these two ratio is same. So RHS will be same. And finally, we'll write AB upon PQ is equal to BC upon QR is equal to AC upon PR. And from 3 and 4, we can say triangle ABC is congruent to triangle PQR. So in this way, using these three ratios, we can say these two triangles are similar according to angle test, AAA test. Here, in the beginning, it is given that the corresponding angles of two triangles are congruent, but finally we get the ratios of corresponding sides of given two triangles are equal. So we prove triangle ABC is similar to triangle PQR using only three conditions. Okay, using only three conditions. Which are those three conditions? The ratio of corresponding sides of both triangles. Okay, this from third and fourth equation we get this step, and then we prove that this ABC and PQR are similar. Okay, so this is for the theorem to prove mathematically, but practically using three congruent angles one can assure about similarity between two triangles. Okay,